example, this one, this example of iron nail. So if you say iron, a clean iron, okay, clean iron, it's only an element, a pure element. If you see this here, it's a only pure element it is. So this one, this iron, it is only having Fe, that is atoms of Fe, that is atoms of iron. But if you see the rusted iron, it is having a combination of elements. That means it is a compound. On rusting, the iron undergoes a chemical change and combines with the atmospheric oxygen to form Fe2O3, that is ferric oxide, or which is also called as iron oxide. So pure iron nail is its element, and on rusting it forms the compound. So I hope this concept of elements and compounds is little bit clear. Okay, so let us move ahead towards the next topic, that this chemical formula, what it tells us actually. Now here, if you see the definition of chemical formula, the chemical formula tells the elements whose atoms are present in the compound. What chemical formula tells? Which elements are in the compound whose atoms are present in this compounds, in that particular compound whose atoms are present. So that's the importance of chemical formula. Now these chemical formulas we are going to use in the chemical reactions. When we'll write the chemical reactions, we are going to use these chemical formulas to write the chemical reactions. So we are going to study this. So here are some examples. Let me first of all, we'll do some questions. Now, for example, this KCl. Can you tell me the name of this compound? KCl. What is the name of this compound? KCl. KCl. What is KCl? KCl is actually called potassium chloride. Okay, it's a potassium chloride. Now, this potassium chloride, how to identify are the atoms present in it. Now, if you see this potassium chloride is having two atoms in it, two elements in it, that is potassium and chlorine. So by combination of potassium and chlorine, the potassium chloride is formed. Second example, if you see sodium oxide, Na2O. Now if you see Na2O, how it is formed? One oxygen atom and two sodium atoms. Now if you see carbon dioxide is made up of two oxygen, one carbon. We see carbon dioxide is present in the nature, that is in the gaseous form. This gaseous form of carbon dioxide is actually made up of these constituent elements, that is carbon and oxygen. If you see oxygen gas, it is present in the nature in this form, that is two oxygen atoms combines to form a O2. Okay, that O2 is a molecule. Now if you see another nitrogen, now nitrogen is formed from, wait a minute, nitrogen is formed by combination of two atoms in it. Okay, similarly sulfur dioxide, if you talk about sulfur dioxide, the sulfur dioxide is made up of one sulfur atom and two oxygen atoms. If you say NaOH, what's the name of NaOH? NaOH is nothing but sodium hydroxide. NaOH is made up of two one Na, one oxygen and one hydrogen. If you see the next example, Fe2O3, that is ferric oxide, it is made up of two iron and three oxygens. So these are the different compounds formed by combination of different elements. So this is how many different chemical formulas we are going to use in this chapter, that is chemical reactions and equations. So this is, I hope this concept of chemical formulas is clear. So next part that we are going to discuss is ions, which is again a very important concept. What is ions? Now, as we have studied in 9th standard, ions are nothing but a charged species, a atom having some charge on it. If you see atom like oxygen, if you say oxygen atoms having 2 minus charge on it. Oxygen atom having 2 minus charge on it. Like for example, O2 minus. We write like this, right? How do we represent an oxygen ion? Oxide ion O2 minus.